Good morning, everybody. This is Sunday. It's September 25th, and we're headed into week 5 of our online astronomy course. Now, before we start talking about the contents of Module 5, I have a few things I want to tell you. And the first thing is that your first exam is going to be next week. Now, let me show you how to find your first exam. You take it online on Canvas. And so let me show you where to go for that. All you have to do is go to the course homepage, right there. Go over to the modules where you normally find your modules, and just scroll down. And between modules 4 and 5, there's your first exam. As it says here, it opens up on Monday, September 26th, and you can take it through next Sunday, which is October 2nd. 35 multiple choice questions. You can use your book, you can use your homework quizzes while you're taking the exam. It's open book, open homework quizzes, but please, no other resources are allowed. You can have a calculator handy. You won't need it, but if you want to have one, just to, feel more comfortable, that's fine too. And you can take each exam twice if you want to. If you want to, you can only take it once if you're happy with your first score. But if you want to try to raise it, you can take it again. And if you take it the second time, between the two, you can take a look at which questions you missed and concentrate on finding the answers to those, and then take it again and hopefully raise your score. And if you do take it twice, I give you the average of your 2 attempts. So that's where to find your first exam. And I hope you all do very well on that. Now, Module 5. Oh, and before Module 5, excuse me, one other thing I wanted to tell you, almost forgot. And what I wanted to tell you is about a NASA mission that's going to be taking place tomorrow on September 26th. And that is when a spacecraft, it's the DART spacecraft, and that stands for Double Asteroid Redirection Test. What they're going to do is they're going to have a collision with a small asteroid that is orbiting a larger asteroid and try to change the orbit of that small asteroid. This is a test of what they might do if they ever find a larger objects that could someday collide with Earth. And so they want to test out techniques on this double asteroid here, one asteroid orbiting another asteroid, where they can see the results more clearly and accurately. So that's going to happen tomorrow on Monday. And if you want to, you can tune in on NASA TV to see it. Here's some information about when that's going to be happening. The coverage starts at 4 o'clock in the afternoon here. That's Utah time. And at 5:14 is when the collision is supposed to happen. There's a camera on board, and I think we're going to be able to actually watch the collision as it happens. So that should be pretty cool. There's a link to this page right here that I'm showing you. There's a link right under the link to this video. Because we do want to protect our planet. I mean, this is the planet that we live on. It's the planet where we know life exists in the universe. And that is what we're going to be talking about and learning about in Module 5. Our planet, right here behind me, our planet Earth. I live just a couple blocks from the 22nd Street Trailhead in Ogden. So this is taken from the trail, looking at our beautiful snow-capped mountains. No snow yet, but fall just began. We're a couple days into fall. Fall started on Thursday. And so today, Sunday, we're just 3 days into fall. Snow will be coming soon. But you know, the Earth has been around a long time. One reason I love living in Ogden among the mountains is that I know these mountains have been here long, long time ago. Hundreds and thousands of years ago, these mountains have still been watching over this landscape that we live in. And it's amazing to think how old Earth is. You know, Earth, according to measurements we've made of radioactive elements that are contained in meteorites that we've found. We can take measurements on the moon to find the moon's age. And our Earth is about 4.6 billion years old. And it's hard to grasp numbers like this. And I like to do it by thinking about a piece of paper, just a narrow piece of paper, like one of those receipts you get from like CVS that go on and on forever. Just imagine one of those pieces of paper wrapped around, all the way around Earth's equator, all the way around it. And that represents the total time that Earth has existed, 4.6 billion years. Well, if you're out there watching, and let's say your age is 21, how much, if you're going to write your life story to scale on that piece of paper going all the way around Earth's equator, where would you, how much of that piece of paper would your life story encompass at age 21? And the answer is about 4.7 centimeters, about 1.8 inches, not even 2 inches would be how much of that paper tape, that paper strip that your life takes up. How about the past 2,000 years? Here we are in 2022. How about the past 2,000 years? How much of the paper does that take up? And the answer is that it takes up only 4.4 meters. And that's only about 14.4 feet. So just not even 15 feet of that is the past 2,000 years. How about the whole history of hominids, the very earliest creatures that we are the descendants of? You know, how long ago were they around? How much of life on Earth was occupied by hominids? How much of the story of Earth was occupied by hominids? On that paper tape, it would be just 8.4 kilometers, about 5.5 miles. I'm sorry, it's about, looking at a number here I have, 8.9 kilometers. I got it a little bit off, about 4.5 miles. So that means that for the huge, huge, huge bulk of Earth's history, there was nobody around. Nobody around. Nobody around to see the continents ride around on the drifting continental plates that rode on top of a layer of Earth that we call the magma. And the magma is just this sort of very thick, molten material that, you know, that hot material rises, cold material falls. That's called convection. And that carries the continents around. And so the continents are crashing together to see form these mountains that you see behind me. And the continents spread apart to form new seas and oceans. And that's been going on since Earth first cooled. So we're going to learn about the entire history of our planet. Really pretty cool. Excuse me. And so it's a fascinating story. You'll learn about how our Earth has a magnetic field that fortunately protects us from high energy particles coming in from space. You'll learn how our magnetic field fades away and then reverses direction every 100,000 years or so, roughly. And you'll learn about our atmosphere and where our atmosphere came from. I know Earth's atmosphere is much different than the atmospheres of any of the other objects that we have in our solar system, any of the other planets, because Earth's atmosphere has oxygen. Now, it's mostly nitrogen, but there is a substantial amount of oxygen, 20-something%. Nitrogen is over 70%. And so we're mostly breathing in nitrogen, but it's the oxygen that we need to stay alive, and we exhale carbon dioxide. But as you know, over the years, the billions of years that there have been plant life, that plant life decayed. Some of it formed coal deposits and fossil fuels that we are burning and releasing too much carbon dioxide into our atmosphere. And that is causing the planet to warm. And our planet's climate is really very, very finely balanced. And so if you change it just a little bit, you can get big changes in our climate. And that's what's happening right now with climate change that has started. And so there's a couple of things in this module to read about climate change from reputable sources, and especially take a look at the forecast for the Southwest region, because this came from, this was published several years ago, and you can just go down and see what they predicted, and yep. Forest fires, check. Droughts, check. Hotter temperatures, check. So climate change has started, and we'll have to do everything we can to try to mitigate its effects and make them not as bad as they might otherwise be. So fascinating to read about our home planet. The next module, we'll talk about our moon, which deserves a chapter to itself. But take a look at this material on Earth. And if you have any questions or comments, you can always contact me by email. We can set up a Zoom meeting, or you can drop by my office and we can talk about things. So before I go, I do want to show you something from Stellarium. So here is Stellarium. And tonight, the 25th, is the full moon. I'm sorry, not the full moon, the new moon. The new moon when the dark side of the moon is facing Earth. Now, this is set up for the 30th, which is this coming Friday, September 30th. This is around 9 at night. And it's just such a pretty sight. The new crescent moon. We're looking south. Now, the Milky Way would be right here in the sky, but the moonlight is washing it out a bit, so it's going to be much harder to see. But it's such a pretty sight. If I just go over here and center on the moon and zoom in on it, there's just this crescent moon. And this red star down here is the star Antares in the constellation of Scorpius. So here is the head of Scorpius. Here's the body of Scorpius, the stinger of the tail. And I can put up the lines here for Scorpius, or even the imagery for Scorpius as we have them in our Western culture. Now, it's sort of interesting because every culture, of course, had looked at the same constellations as we do. And it's sort of cool to take a look at how how other cultures may have taken a look at Scorpius. So I'm going to pull up this tab on Skylore. And for instance, the Navajo people, if we take a look how the Navajo people may have pictured Scorpius, it was part of a figure they called the first big one. And over here, the tail of Scorpius, they called rabbit tracks. If I go to another culture, let's take a look. We might take a look at, let's take a look at the Polynesian culture. And here is Scorpius, including the tail, as Maui's fishhook. And finally, if I go up here and take a look at the Aztec cultures, just to choose 3, I notice that there are links that tell you more about these cultures on this tab that I'm looking at. But take a look, the Aztecs also identified this with a scorpion. They call it scorpion face. I won't try to pronounce the Aztec word, but they saw this as the face of a scorpion. So I think all of that is really pretty cool. Also, if you go out, this is one of my favorite times of the year to look north, because looking north, right about like this, here we go. I'm going to zoom out a little bit more. Here is the Big Dipper. And the Big Dipper is right side up. It's like you can see that it's a bowl trying to dip water. I'll just tell you that this star right here is called Doobie at the end of the bowl of the Big Dipper. And that is, no kidding, Utah's state star. Doobie, D-U-B-H-E, an old Arabic name. And the 2 stars at the end of the bowl of the Big Dipper, if you go from the lower one through the upper one, keep on going straight, you hit Polaris, the pole star directly above Earth's North Pole. So this is a fun time to see the sky. And I hope you will go outside and take a look at it. So good luck on your exam. I hope all goes well. And I'll look forward to seeing you next time. So until then, have a great week. Bye-bye.